The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
All right. Well, hello everybody. I'm Doug Burks. I'm very excited to be here. Charlotte is kind of a second home for me. My in-laws live here, so I'm up here every couple of months visiting them. I love the city. It's a great city. Let's see. Is my computer going to work? There we go. So here's me. I'm a Christian, I'm a husband, I'm a father, and in my spare time, I'm a security guy. So I'm a SANS GSE. There's about 70 of us in the world. I also teach some classes for SANS, so I teach intrusion detection and some other things. I work for a little security company called Mandiant. You may have heard of us. We released this little report on the Chinese back in February. So we made some waves with that. And oh, by the way, we're hiring, so if you're interested in doing really cool security work, come and talk to me after my talk, and we can talk about our positions that we're hiring for. We have all kinds of cool stuff from reverse engineering to intrusion detection to basically anything you want to do in the security realm. If you're on Twitter, I am Doug Burks, and I also have Security Onion there. If you'd like to live tweet this event, which my good friend Lawrence is going to be live tweeting, you can use hashtag SecurityOnion. So that's me. So let me ask you guys, so who here is responsible for defending a network? Probably about half of you. Okay, so for those of you who didn't raise your hand, do you have possibly an internet connection at home that you'd like to get some more visibility into? You'd like to see what's going on? Yeah, maybe a few of you. So maybe we can help you with that. So what is Security Onion? Security Onion is a free Linux distro for intrusion detection and network security monitoring. It's based on Ubuntu. We've got Snort, Suricata, Bro, Squeal, Elsa, all these cool security tools that you need to have visibility into your network. So the history of Security Onion, it started back in 2008. I said, you know what? Folks have Snort. They can go and download the tarball for Snort, and they can compile it, and they can configure it, but they spend hours on that, and they just have Snort. And then maybe they go and they download Base, and they install PHP, and they configure that, and they get it running, and then after a few more days of tinkering, they finally have this graphical user interface for Snort. But that's really not everything that you need to have full visibility into your network. So I said, you know what, we need something better. We need a better way of doing all this. You know, we are supposed to be defending our networks. We shouldn't be spending most of our time doing sysadmin work just trying to keep our sensors running. So let's focus on defending our networks. So in 2008, I had this idea. I started building it, released the first version in 2009. And back then, it just had Snort and Squeal. That was it. In 2010, I created a new ISO release. It was based on Ubuntu 10.04. I added a few things like Suricata and OSEC and Squirt. The next year, 2011, people actually started using it. It was weird. You know, this was just my personal little pet project. I never expected anybody to really take it and deploy it in production. That's ridiculous. But people did. And so instead of releasing a new ISO image every year, I had to come up with a way of deploying in-place upgrades. So I wrote this little cheesy shell script that would do in-place upgrades. And via that shell script, we were able to deploy Argus, Bro, Network Miner, Snorby, and support for distributed sensors. You could have a whole army of sensors all reporting back to one central interface. So then last year, 2012, Ubuntu released 12.04. So I said, okay, this is my opportunity to make a real, true, enterprise-grade Security Onion. So we're going to be based on Ubuntu 12.04. We're going to go 64-bit by default. We're going to put all of our software into packages and host it in an Ubuntu Launchpad PPA. So no more cheesy shell script. You now have true packages in true package management. I finally, after months and months of hard work, released Security Onion 12.04 on December 31st, 2012. So if you look at some metrics for Security Onion, the old 10.04 version, the ISO image, was downloaded from SourceForge 37,000 times. The new version, 12.04, that we released December 31st, in just the past few months has been downloaded 33,000 times. We also have BitTorrent available, so we have no idea how many folks are using BitTorrent. We also have folks who just install via a standard Ubuntu ISO image, then add our PPA and add our packages. So of course we have no metrics there. So the long and short of it is we've got a good number of users out there. So let's talk about some of the design goals of this new version of Security Onion. As I mentioned before, we based it on Ubuntu 12.04. We default to 64-bit, so if you download our ISO image, it is 64-bit. If you want to, you can start with your own version of Ubuntu, so you could pick regular Ubuntu or Kubuntu or Lubuntu, whatever you want. You can use 32-bit or 64-bit. You can add our PPA, add our packages, and you'll be up and running in just a few minutes. Now, when it comes to high performance, we really needed to be able to monitor networks that were gigabit and higher without dropping packets. So we had to come up with, we had to really up our game to be able to handle that amount of bandwidth. So for Snort, Suricata, and Bro, we use a piece of software called PFRing. So PFRing is a kernel module that basically acts as a flow-based load balancer so that you can take, whereas a normal single instance of Snort may only be able to handle 100, maybe 200 megabits of traffic, we can take that gigabit worth of traffic, cut it up into 6 chunks, and then spin up enough Snort instances to handle that amount of traffic. So PFRing is the magic that allows us to do that. We also have NetSniffNG, which is doing full packet capture for us, and it uses zero copy so that it can really write those packets to disk as fast as possible without dropping them. Now, when it comes to graphical user interfaces, we've got a new GUI called ELSA, which is basically like a free version of Splunk. So it's a way of hunting through your logs, and that could be your Snort logs, your OSEC logs, your standard sys log, what have you. And the way that we architect that in our deployment is that every single Security Onion box is an ELSA log node. And all of those ELSA log nodes are queried by the central ELSA web interface in parallel, right? So instead of having all of your logs going to this one central MySQL database, you've got all of these distributed MySQL databases all over your enterprise, and you're querying them at one spot in one shot. So it makes it much higher performance. Here's a picture of what that looks like. So our architecture is such that we've got our master server, that's our ELSA web interface, and it's also got some other server components which talk to the sensor components that are down on the sensor nodes. We try to keep as much data as close to its point of origin as possible. So that means things like full packet capture is going to stay on the local sensor. Things like all of our Bro logs, which we'll talk about in a minute, all those Bro logs will stay on the local sensor. So wherever the data originated, we want to keep it there. So imagine that the line between the sensor and the server, maybe that's just a low bandwidth like a T1 to your remote branch office, right? You don't want to be clogging that up by sending all this security information up to your master server. So let's keep it at the point of origin. So I mentioned before that Security Onion kind of grew out of this need that, a lot of folks were just using Snort, and just using Snort isn't really going to cut it. So the idea is that an IDS alert on its own doesn't provide you enough intelligence. You don't really know if that IDS alert on its own was a true positive or a false positive. So there's this concept of network security monitoring, NSM. And one of the core tenets of NSM is that an IDS alert alone is not enough. We need context around that IDS alert. That context can come in many different forms, and we want to collect as much context in as many different forms as possible. So we start off with our alert data. We start off with network-based IDS alerts from either Snort or Suricata. We also have host-based IDS alerts coming from OSEC. So OSEC is this great cross-platform host-based intrusion detection system. It does log collection and analysis, it does file integrity checking, and it does rootkit detection. So you can install the OSEC agent on your Active Directory domain controllers, your Exchange boxes, your mission-critical Unix and Linux boxes, your Mac OS machines, what have you, and have them all reporting back to your Security Onion box. Next up, we have asset data. So this is things like this IP address is running Windows XP and it's running the Google Chrome browser. Asset data. We have that coming from two different sources, from Bro and from Prads. We have it coming from two different sources because they're feeding two separate databases, which we'll look at in the demo later on. We also have session data. So this is, if you're familiar with Cisco NetFlow, it's very similar to NetFlow in that it's just this IP address talk to this IP address on this port for this amount of time, this many packets. We have that coming from Argus, from Bro, and from Prads. Then we have transaction data. So this is things like HTTP logs, like you might see on an HTTP proxy server. FTP logs, DNS logs, SSL logs. All these are coming from Bro. Bro is this amazing piece of software that's listening to your network traffic, and it's creating all these well-formed ASCII text logs that are easily parsable by your standard Unix command line utilities. And we've also got those logs available in ELSA. So we'll show you in a few minutes how you can use ELSA to slice and dice those logs and really understand what's going on in your network. And then finally, I mentioned before, we do full packet captures. We have full content data coming from NetSniff-NG. So even if all of the data types above don't give us what we're looking for, we're recording every single packet that traverses the wire. So we can really and truly do a full investigation. So one of the core pieces of Security Onion, which goes along with the whole NSM discussion, so the one true open source implementation of NSM is Squeal. Has anybody played with Squeal, familiar with it? A few folks. So Squeal has been around for a long time. As a matter of fact, it started off 10 years ago. And so the guy who wrote Squeal, his name is Bam Vischer, super smart guy. He said, you know, we need to implement this NSM model. We need to be collecting all of this data, and we need to give the analyst the ability to pivot from one data type to another seamlessly. So this is kind of what it looks like. So you've got all these components. You've got your full content data. You've got your session data, your asset data. You've got all that data going into Squeal, which writes it into a MySQL database. You've got sensors that are capturing that. You've got an analyst that connects to Squeal to retrieve that information. And if you were to go and manually install Squeal, so you'd go to the Squeal wiki, and you'd see this long how-to document. And you'd spend days, possibly weeks, possibly even months trying to get Squeal up and running if you were to try to compile and configure all of this software to put this jigsaw puzzle together. So that was one of the difficulties of really trying to give analysts the tools they need, was because it was very difficult. But if we can give you a nice next finish wizard to take care of all this for you, then again, that's going to let you focus less on being a sysadmin and more on actually defending your enterprise. So that's what we did for Security Onion. We've got this nice wizard that asks you a few simple questions. You click next finish, and it does all the hard work for you. So all the software is already pre-compiled. All it does is take the answers that you provided, and it goes and configures everything for you behind the scenes. And a few minutes later, you have a fully operational NSM system with all of the components that we talked about. So what I'm going to show you in the demo is we have really four main interfaces for you as the analyst. The first that I'm going to show you is Snorby. So Snorby is a very new web-based interface. It's Ajax, it's Ruby on Rails, it's Web 2.0, it's all that cool hipster stuff that all the kids are crazy about. So it's very cool, it's very flashy, and it gives you your IDS alerts. We have the capability of going from an IDS alert and pivoting to full packet capture, so you can actually render a transcript of the entire conversation. So that's very cool. But Snorby, even though it's beautiful, it doesn't provide access to all of those data types that we talked about earlier. And here's a screenshot of pivoting to PCAP from Snorby. That goes to a web interface called CapMe. And we'll show all this in the demo. So the next web interface we have is called Squirt. Squirt is a web-based interface to the Squeal database. Squirt is very nice in that it provides you access to more of the data types that we're capturing. So it gives you access to not only the network-based IDS alerts, but also the host-based IDS alerts. It also gives you access to the asset data and some of the session data as well. And it gives you some nice reporting for management, some nice summary statistics, some nice pretty charts for the manager types. Then we're going to look at the third interface, which is the Squeal client. And as I said, Squeal was written 10 years ago. So it's not a modern user interface. It's written in TickleTK. But what it lacks in prettiness, it more than makes up for in usability and the amount of power that it gives you as the analyst to take this data and slice and dice it and pivot from one data type to another and really understand what's going on in your network. So we'll look at the Squeal client. And we'll see how in the Squeal client you can very easily pivot from, say, an IDS alert to full packet capture. And we can render that full packet capture as a transcript. That's what you see on the left. Or we can take the PCAP and we can actually send it directly into Wireshark. We can also send that PCAP directly to Network Miner. So you can use Network Miner to very easily extract files from your PCAPs or do other cool things. And then finally we'll look at the fourth interface, which is ELSA. And as I mentioned before, ELSA is similar to Splunk. It's a web-based interface for hunting through your logs. So we take all of our bro logs, so that's like the HTTP log, the FTP log, the DNS log. We take all of this asset data. We take all of our IDS alerts. We take all of our syslog. We take all of our OSEC logs. And we throw them into ELSA. So you have this big old pile of data sitting at your fingertips that you can slice and dice however you need to answer the questions that you need to answer for your organization. And of course, inside of ELSA, if you have anything with an IP address and a port, we can take that and we can pivot to a full transcript of that entire TCP conversation, just like we did with Snorby. ELSA has some nice pretty dashboards, again, for the manager types. And you can do cool things with inside of Bro, it has this log called the con log, the connection log. And this is session data. So you can do things like show me all of the flows from this IP address for this specific time period. And then you can cut through that and you can slice and dice it and say, show me all of the unique IPs that this workstation communicated with for the past day. Then show me all the unique ports that it talked on. And then maybe you find something interesting, so you drill into that. And then maybe you're interested in one of those, so you then pivot to PCAP, right? So you then see, based on that full packet capture, exactly what happened. Some guy down here is nodding his head. He's seeing how cool this is and how much he could use that every single day.
Looking for this stuff for years and not finding it.
Yeah, you found it. All right, so it's demo time. All right, so let's see. Is that time accurate? 1:48. All right, so what I have here is I have two virtual machines. And the only thing I've done is I've installed from our standard ISO image. So it's the standard Ubuntu installation. You walk through, you do the Ubuntu installer, you reboot. I've done phase 1 of our setup wizard, which is basically just specifying which interfaces are used for management or for sniffing and assigning IP addresses and stuff like that. But that's really all I've done, okay? So what I'm going to show you now is running through phase 2 of our setup wizard, which is asking you the questions to configure all this stuff and configure it behind the scenes. So what I will show you is that within 10 minutes, we can configure all this software and have it up and running. Software that would have taken you days, weeks, or months to do by hand. All right, so here we go. So we've already configured our network interfaces. So the first real question that we have is, would you like to use quick setup or advanced setup? So if it's your first time using Security Onion, so if you go home today and you're interested and you download the ISO image and you want to play with it, I recommend for your first time that you choose quick setup. It's going to ask you the absolute minimum number of questions to get you up and running as quickly as possible. Now once you've installed Security Onion a couple of times and you've played with it and you want some more control over your installation, then you can choose the advanced setup. It's going to ask you more questions. You're going to need to know more about your setup and your network and the things that you want to monitor, but it gives you more control. So for this first VM, we're just going to do a quick setup. So which network interface should Snort listen on? That's going to be Ethernet 1. So both of these virtual machines, they have 2 network interfaces. And what we recommend is you always have one NIC dedicated for management. That's going to have an IP address. That's what you're going to use to SSH into it or to access the web-based interfaces, what have you. And then you have other interfaces that are dedicated for sniffing. So in this case, for both these VMs, Ethernet 0 is our management interface and Ethernet 1 is our sniffing interface. So Snort's going to be listening on Ethernet 1. What would you like your Squeal username to be? Doug. What's your email address? Doug@burks.com. What would you like to set your password to? Confirm your password. Would you like to enable ELSA? Yeah, because we want to be able to slice and dice all these logs. All right, so that's it. That's the only questions that we have to answer for quick setup, okay? So it's confirming all the choices that we've made. Are you sure you want to continue? Yes, proceed with the changes. So right now it's configuring OSSEC. It's creating the Squeal server. We have no internet connection, so we can't download rules, but that's okay. Right now we're initializing the Snorby database. That's going to take another minute or two, and then it will go on and configure ELSA. So as I said before, when setup completes, we'll go through each of the 4 interfaces that you have as an analyst to use and to look at all of the information that these sensors are providing about your network. All right, so we're done, right? Did I come through on my promise of less than 10 minutes to be up and running with all this amazing software? All right, so it just tells you some final information here about you can look at the setup log file, you can look at the bro logs. Here's where you can go to modify some of the settings on the system. And if you have any questions, you can go look at our website where we have frequently asked questions, we have a wiki, we have mailing lists, so on and so forth. So we're done, right? Everything is up and running. We can verify that by opening up a terminal and doing service NSM status. And we've got a bunch of green OKs, so everything is up and running. You can see there we've got our Squeal server, we've got our OSSEC agent, we've got Bro up and running, we've got NetSniff NG that's doing our full packet capture, we've got the PCAP agent, which is responsible for bridging that full packet capture to Squeal and back and forth. We've got the Snort agent, which does the same thing for Snort, so the Snort alerts pass through the Snort agent to get to Squeal. We've got Barnyard 2, we've got PRADS, we've got the SANCP agent, the PADS agent. Both those 2 agents are pulling data from PRADS and sending them to Squeal. We've got Argus, which is sniffing network traffic and writing session data to disk. And we've got HTTP agents. So all the bro HTTP logs go into our squeal database so that if you see an IDS alert for black hole exploit kit, you can pivot on that IP address and you can see the exact chain of events where the user went to Google, they searched for something, it led them to some Russian site, and boom, they got popped. All right, so everything's up and running. So let's go and look at our first interface. So this is going to be Snorby. And please, as I'm going along, if you have questions, please feel free to stop me, ask your questions. I love having Yes, sir.
So all this full packet capture we're looking at, like, are we doing full packet capture on every packet, or only beginning with IDS alerts, or what's going on with that?
Full packet capture, every single packet. So it's going to store full packet capture for as much disk space as you have. Okay. So we have an hourly cron job that looks at your disk space, and as soon as you hit 90%, it's going to start rolling off the old PCAPs so that you don't fill up your disk. So you know, that's one of the biggest issues that most new Security Onion users have, is that they're used to sizing their sensors based on their traditional method of thinking when it comes to, I'm deploying an IDS sensor, I'm not doing full packet capture, so I don't need a lot of disk. So they get into trouble when they deploy Security Onion, and they deploy it on undersized hardware, and boom, it's so undersized that it's actually filling to 100% before our cron job can fix it. So we do recommend to folks that you make sure you understand how much traffic you're actually monitoring, so that you can size your storage appropriately.
I'd be worried about a user hitting a file server up for a few gigs of data and just blowing through everything I wanted to look at before I could get to it.
Yeah, I mean, the thing is, disk is cheap, so we recommend that folks look at many terabytes on their sensors. So typically, the sensors that I deploy nowadays are based on Dell PowerEdge R720s. And we deploy about 20 terabytes per sensor. So that, in most cases, that gives us a good solid month or two of full packet capture. All right, so we're logged into Snorby. Now notice we have no alerts here because we don't have any traffic yet. But, and this would be a very boring demo if we didn't have any traffic. So I happen to bring some traffic, okay? So we'll use TCP replay. And we've
much trouble with the disks not keeping up with traffic in bigger networks?
We have not really had any complaints about that. I think you could probably shoot yourself in the foot if you're running really old hardware that had a really slow bus and couldn't keep up. But I think modern hardware is pretty good, and NetSniffNG is actually very good when it comes to optimizing the write to disk. So NetSniffNG by default uses a scatter-gather method. So it's gathering a whole chunk of traffic, and then it will spool that big chunk to disk in one block. It's very well optimized when it comes to taking care of that.
Doug, is it only storing it in one spot, or is it storing it multiple times? So you've got Wireshark that's running on the background of this thing that's capturing PCAP files. Is it using the same PCAP files, or is it creating a mirror PCAP file?
No, so we don't use Wireshark for full packet capture. We use NetSniffNG for that. So it's doing the full packet capture to disk, and that's being stored in a directory. And then when you as the analyst log into Squeal or one of our other interfaces and you go and request a PCAP, it comes from that PCAP store that was written by NetSniffNG.
So like one time?
Right.
Okay.
All right, so I've got some PCAPs here, and I'm just going to replay all of them. So my production sensors nowadays are generally about 128 gigs of RAM. So yeah, we basically take a Dell PowerEdge R720 and max it out. all the RAM, all the CPU, all the disk you can get.
So I guess the next question is, do they actually need all that RAM, or do you have any idea?
It really depends on how much traffic you're monitoring. When you're talking about running all the sniffer processes that we run, and if you're monitoring, say, a couple hundred megabits of traffic up to gigabit and more, you definitely need lots of RAM. All right, so we should have some traffic now. So if I refresh this, force a cache update.
What size deployments are you putting these sniffers in that you got these maxed out power edges?
What size deployments?
Yeah, I
Meaning,
mean, like, are you dropping these into, you know, like 500 desktop orgs or small business? Or
most of the sensors that I have currently are smaller than that. But the thing is that because of our architectural model, even if one sensor can't support the number of desktops or the amount of traffic that you're trying to monitor, it's actually pretty easy to isolate your traffic, send it to multiple sensors, and because we support a distributed sensor model, all those sensors are going to be managed by one interface anyway. So it really doesn't matter how many sensors you have on the back end. So I mean, you could say, hey, I've got so much traffic, I really need to buy a commercial C-packet flow-based load balancer, and I need to cut my traffic into 10 slices and run 10 security onion boxes.
I'm actually trying to figure it out from the other side. I'm a small biz guy, and most of my businesses are, you know, they're more like 20 desktops.
Oh,
And
okay.
I'm trying to figure out, you know, would it be because I'm not gonna be able to get them to say, oh yeah, we'll drop the money on a, you know, completely maxed out power edge plus hiring plus blah blah blah. So I'm wondering, like, how far can you scale it down for, you know, smaller situations?
Yeah, it just all depends on your amount of traffic. Yes?
We're running it on an old server that's got 16 gigs of RAM and a single Xeon processor on it for 150 workstations. That is working beautifully.
That's the answer I wanted.
Yeah, I mean, so when I talk about running a maxed out R720, I have a pretty big hardware budget. Money's not really an issue for me. I'm more concerned about not dropping packets ever.
Sure.
So I very much overbuild my sensors to make sure that I never drop packets. You can certainly go with a much smaller sensor if you don't mind dropping packets every now and then. And you'll still, even if you are dropping some packets every now and then, you're still getting valuable intelligence about your network. So it's still creating value even if you are on an older or underpowered sensor. All right, so here's our Snorby dashboard. And as you can see, we've got these nice pretty tabs that you can look at severities and protocols, and you can look at signatures and, you know, nice pretty colors. Managers love this kind of stuff, right? And you can go to sources and destinations, and you can look at these things. You can go on over to events, and this is where all of your IDS alerts are going to be in. Remember, Snorby just has network-based IDS alerts from Snort or Suricata. That's the only data type that you're going to have in Snorby. So it's beautiful, but it's somewhat limited in the amount of data it gives you. But for these IDS alerts, you can take and drill into it and say, okay, this is an ET policy suspicious doc.exe in the HTTP URL. So that's interesting, so let's drill into that. So you have your traditional source IP and destination IP, source port, destination port. You've got the little bit of the TCP payload that actually generated the alert. So this is just a little bit that matched against the IDS signature, but this is not the full packet capture, okay? So generally speaking, this little bit right here is not going to be enough to tell you whether this is a true positive or a false positive. In order to really investigate this, we need full packet capture. So we go to packet capture options, we go to custom, we go to fetch packet, we proceed. We proceed. And here is our transcript. This is the entire TCP conversation. This is all of the context around that IDS alert. Okay, so my analogy for IDS versus NSM is the difference between a snapshot in time or full video recording. So if you've got a house and you want a physical security system for your house, right, you go and buy one, they come and install it, and you find out that it's just a motion-activated camera, right? So you go and review this thing, and you have this snapshot of this guy, so you don't know if he knocked on your door and walked away, or if he broke down your door and stole your TV, right? But if you have full video recording, you know exactly what happened. It's the same thing with full packet capture, right? We know exactly what happened before and after. And of course, you can see here that here's the GET request. This is what triggered the IDS alert. And you can see in the server's response, you see the telltale sign of the MZ header, and then this program cannot be run in DOS mode. So this actually was a Windows executable that was sent to this particular IP address. So you can do all kinds of cool stuff with these IDS alerts in Snorby. But as I said, it's really just limited to those data types. So let's move on to our next interface, and that's going to be Squirt. And remember I said that you're going to have access to more data types in Squirt. So you'll see things like OSEC. So remember, OSEC is a host-based intrusion detection system. You'll be able to see those. You'll see down here, so here's an OSEC alert for integrity checksum changed. Remember, OSEC does file integrity checking. We have some emerging threats, IDS alerts. And again, this is a dashboard, kind of like how we saw in Snorby. We can go across the top, and we can go to signatures, and we can look at those. Again, some nice pretty colors for the management types. Got some nice pretty graphs for top source IPs and destination IPs. We've got a world map if you want to do geo IP-based lookups and see what alerts you're getting from China or Russia. Then you can go to query and you can say, hey, I want to see everything for the past 24 hours. And notice in this list, we've got a few different data types there. So we've got some OSEC alerts. We've got some PADS, new assets. So remember we said that we have asset data coming from PADS. So in this case, it actually found an FTP conversation. So it found either an FTP client or an FTP server. So now that we know that that asset is on our network. We also have URL logs. So here we have one. This is an HTTP log just going to an IP address 66.32.whatever. So that's interesting. So what if I view event detail and submit that? If I want to find out more about that, I can click that and I can see, okay, so this was a GET request to that host. Here was the URI. So this is actually the same exact thing that we just looked at in Snorby. This was the .doc.exe. And so we were able to see in this case, here was another indicator that this was suspicious. Just the fact that somebody went to an HTTP, did an HTTP request to a site using just an IP address outside of our network, that's a little odd. Generally, folks are using fully qualified domain names. So are you starting to see the wealth of data that we have here and how all of this intelligence helps you do your job? So we've got all this information, again, URL logs, IDS alerts, asset data, all kinds of good stuff. So that's Squirt. So now let's move into Squeal. This is the third interface that we have. It's written in TickleTK. So Squirt is amazingly powerful. One of the things that I really like about Squirt from an analyst perspective is the fact that it gives me access to a ton of information in one pane of glass. What do I mean by that? So I can select one of these alerts. I can turn on show packet data and show packet rule. We're going to be somewhat limited by our resolution here, but you see the IDS rule that generated the alert. You see the IP header, the TCP header, and the data in the payload. You could turn on reverse DNS. You could turn on whois if we had an internet connection. So you could have all of this information at your fingertips without having to double-click on an alert and double-click on another window and double-click on another window, as I have experienced in many commercial IDS appliances in my years. So let's see. Another thing that we can do in SouthEast, which is highly powerful, is, I think I have angered it. So we can instantly pivot to full packet capture. So if I just control-click on the alert ID for the IDS alert, it's going to go to that PCAP store, it's going to pull back the entire PCAP, the entire TCP stream, and render it as a transcript in my window here. And again, it's the same .doc.exe that we've been looking at, and we see it in the window there. So now let's say that we wanted to do some further investigation on that particular alert. Well, so instead of control-clicking and getting a transcript, let's actually send that PCAP into Wireshark. So it's going to go to the PCAP store, pull the TCP conversation out, write it into a PCAP, give that PCAP to me, and then spawn Wireshark. So I now have it in Wireshark. Right? So I can do whatever I want to do in Wireshark. You know, I could follow a TCP stream. That's the same kind of transcript thing that we saw before. If we wanted to extract the EXE, we could go to File, Export, Objects, HTTP, and we could actually save that executable right out of the PCAP, and we could do, you know, some reverse engineering on that EXE if we wanted to. Now let me show you another way of doing that. So instead of sending the PCAP into Wireshark, I could send it in a Network Miner, and Network Miner is actually going to extract it automatically. So I can just say, open the folder, and there's our EXE. Right, so I could go to my terminal window, and I could use the file command just to verify that this is actually a PE32 executable for Windows. Right, so we can do reverse engineering on the executable, whatever we want to do. Now you do. All right, so inside of SouthEast, you can pivot from all these data types. So you could say, okay, this workstation, I'm really concerned about it. I want to see everything that we know about it in the event table. So I'm going to query for that, source IP. So again, we have new asset data, and we're being limited by our resolution, but so you'd have information about the assets that we discovered on that IP, so the operating system, the browsers in use, the services that it contacted. So you'll see the other IDS alerts for that IP address. At some point, we should see, yep, there's our URL. So that's our HTTP log and some more pads assets. Anything in SouthEast that has IP addresses and ports, again, you can pivot to PCAP or transcript. And then we could also say, we want to pivot to our session data. So we want to see all of the conversations, all the traffic for this particular IP address. So let's query the SANCP table on the source IP. And so here's just kind of a summary view of here's all the IP addresses that this workstation talked to. Here's all the ports. Here's how many packets. Here's how many bytes, so on and so forth. And again, if we found something of interest, like this FTP conversation, we could pivot right to transcript. We'd say, oh, they downloaded gsec dump. Should that workstation be playing with gsec dump? Possibly not. Maybe we need to investigate that. All right, so that's SouthEast. So
in that case, were you seeing the new asset pop up because whatever malware they've run and spurted up the server?
that could be the case. So if the malware starts up a backdoor, it starts listening on a port, then PADS is going to see that, assuming there's traffic actually coming into that port. then it will alert you to that. So it might say, hey, you've got a workstation listening on port 31337. You might want to look into that, right? All right, so finally we need to look at ELSA. And how long do I have? I have till 2:30, is that correct? Okay, I got to move it. So, here's ELSA. Remember, this is our web-based interface. So we can do things like group by program. Here's some of the log types that we have. So you can look at OSEC archive logs. You can look at OSEC alerts. You can look at cron information, sudo logs, refresh the page. Then you start getting into some of the bro logs. So bro connection records, we can take and group by destination IP. So here's our top talkers on the network. We can go and group by destination port. So here's the ports. If we see an interesting port, we can drill into that. And you can pivot to your heart's desire. So those are connection records. Now, one of the things that I really like to do is look at every single DNS query on my network, right? So I look at all these DNS queries, I group by host name, and Bro does something interesting in that not only is it capturing true DNS queries, it's also capturing like Windows NetBIOS name queries, and it's writing those, and so that's why you see things like workgroup. So I can filter those out just by adding 53. So I can look through all my DNS requests and I see, nrtjo.eu. That's interesting. Maybe we might want to look more into that. So maybe my next step might be looking at my HTTP logs, grouping by site, and then I could see nrtjo.eu. Right, so here's my requests that went to that particular site. So I could pivot on those. For any of these that I want to see the transcript for, I can click Info and plug in and get PCAP. And bingo, there's my transcript. So I can see the entire conversation. So let's go back here, because I saw another one that looked interesting to me. Sploitme.com.cn. That's fine. I'm sure that's legitimate, right? So what is that? What's going on there? So let's pivot on that one, plug in, get PCAP. All right, so we did a request to / click equals this random string. And then we had show.php. Interesting stuff. So maybe that merits further investigation. All right, so we can look at HTTP logs. We can look at SSL certs. So obviously we can't see encrypted data, but we can see the SSL cert as it's exchanged. Yes, sir?
So why would you wait until .cn shows up on your dashboard versus just shutting it off beforehand?
That's a great question. So I'll tell you a little story. Okay. You know, we at Mandiant, we released this report on the Chinese back in February, and we started seeing a lot of traffic from China.
Is that Richard
Baitlick. He's my boss, yeah. So started seeing a lot of traffic from China. We didn't want to deal with it, so we blocked all of China. So if you don't do business in China, block them. That's what I do. Yeah, sure. Sure. That's a totally legitimate defense strategy. All right, so we can look at our SSL logs, so we can take a look at all the fields in those SSL certs that are negotiated across our wires, and we can see interesting things there. Now, before I run out of time, I need to show you our second sensor. So I've got a second VM here, and we're going to run through the setup wizard. And yes, so now this time, instead of doing quick setup, we're going to do advanced setup, because this is what we have to do in order to say this is going to be a sensor that reports back to our central interface. So we're going to do advanced setup. We're going to choose sensor. And we're going to say our master server is BSidesCLT1. And username, we're going to monitor ETH1. And we'll just do one instance and one instance. And enable ELSA and update the ELSA server and proceed. So again, we've given it all the information it needs. It's going to go behind the scenes, configure all the software, and it's going to SSH to our server and configure the server side. And we set up a public-private key pair there so that we can build an SSH tunnel so we can tunnel some traffic from the sensor to the server and vice versa. And we update the ELSA web server so that it knows about our new ELSA log node. So now if I go back here and go to Squeal and expand this and go to File, Change Monitored Networks. So notice I have BSides Charlotte 1 and BSides Charlotte 2. Charlotte 2 is our new sensor. So we tell it we want to monitor that. And then if I SSH into BSides Charlotte 2, so I'm going to create some traffic over here. And we'll use some different PCAPs this time. */*. So what we should see if this works, if you'll notice in the background, Squeal is going crazy with all these new alerts from BSides Charlotte 2. Right? So in just a few minutes, we have built a distributed sensor deployment. Very simple, just a few simple, easy questions. Even a Windows admin could do this. All right, so the other thing that I want to show you is back in ELSA, if everything worked correctly. It should update from one node to two. Come on, there you go. So ELSA has 2 nodes, so we should be able to do the same thing there. And ELSA should have all of our snort alerts from the PCAPs that we just replayed. So there you go.
Does it SSH with, I guess, your custom code, or does it have like a default?
So when you run the setup wizard and you say, I want this to be a sensor, it's going to ask you for the account that you want to use. And that's the account it's going to use to create that SSH tunnel, and it's going to automatically create the key pair.
So it's not using like a default.
Yeah, we wouldn't do that. All right, so now that I have preached to you the gospel of Security Onion and you're very excited about running it on your network, just go to securityonion.blogspot.com. We've got a link for downloading the ISO image. You can get it from SourceForge or from Torrent. We've got a nice install guide there. We've got frequently asked questions. We've got mailing lists, IRC channel. And so very quickly, any questions? I see one back there. The cost to a big enterprise is $0 other than hardware.
You would have to pay for like snort signatures or anything like that? Is that coming through you guys already?
So you can get snort signatures for free from either the Emerging Threats project, or you can choose the SourceFire VRT registered user, which is free. You just get rules on a 30-day delay. So you don't have to pay for rules, but you can if you want to. Yes, sir?
What about using alternative data sources? I have Squid set up with SSL bump. Can it shoot its interpreted data before I can decrypt SSL?
So that's a great question. The gentleman asked about other data sources. One in particular is Squid with SSL bump. So I don't have any experience with SSL bump in particular. I know that one of our community members has a project called ViewSSLD, which does something very similar as far as decrypting SSL traffic. So I know that it's possible, and I would, I'm sorry? That's a good question too. We would like to get into doing stuff like that, so maybe we should talk offline. Any other questions? Yes, sir.
One thing I did not see was, and I don't know if it's just, if it's not there, you just weren't showing it. Is there an easy way to filter the traffic you're looking to log by MAC address rather than by source IP?
Well, typically in large enterprises, well, okay, so most of the stuff that we do is more based on IP address than MAC address. Typically.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication. From Wicked.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source. The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how Cloud Stack is being built. Nothing is proprietary. Everything is open.
in many ways it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you will you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. These hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and the administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again,